Our focus for this section is going to be on exponents, and we want to start that discussion by talking about a specific type of expression that involves exponents that we refer to as a polynomial. A polynomial is written in a general form here, where we have a sub n times x to the nth power plus a sub n minus 1 times x to the n minus 1, and so on until we get to that last term, a sub 0. Written as general form, it can look a little confusing, but really all we're saying here is that each a value is some coefficient, so some number times a variable raised to a whole number power. And then we have one or more terms. And when we get down to these final two terms, we see that pattern start to look a little bit different. But really it does follow that same pattern, because in the second to last term, we have a sub 1 times x, which is really the same thing as x to the first, plus a sub 0. But we could rewrite this as a sub 0 times x to the 0 power, where anything raised to the 0 power is just equal to 1. So we eliminate those pieces. But each term of this polynomial expression has a variable multiplied by a coefficient, so multiplied by some number, raised to a whole number power. We have a few different specific types of polynomials. For instance, we have monomials, which is a polynomial with a single term, that prefix mono, meaning 1. This would be something like 7x squared. It's a single term, but we have a coefficient multiplied by a variable raised to a whole number power. We also have binomials, where we have that prefix bi, meaning 2. So that's a polynomial with two terms, something like 7x squared plus 8x cubed. Then we could have a trinomial, which would be three terms with that prefix tri. And that would be something like 7x squared plus 8x cubed plus, say, 6. And then we could have a polynomial with 4 terms, 5 terms, and so on. But we really only give kind of a special term, special name to these three cases, where we have 1, 2, or 3 terms in our polynomial. And then each polynomial has a degree, which is the largest power present in that polynomial. So for our monomial, 7x squared, this would be a second degree polynomial. When we look at that binomial, 7x squared plus 8x cubed, 3 is the highest power, so this would be a third degree polynomial. And the trinomial that we have here would still be a third degree polynomial because we added one additional term, but really that's being multiplied by x to the 0 power. So this is still a third degree polynomial because 3 is still the highest, the largest exponent that we see. I'll just rewrite that with a little more room here. So every polynomial has a degree, which we identify by identifying the largest power and a leading term. And that is the term with the highest power. So when we look at 7x squared, there's only a single term, so that's the leading term. When we look at 7x squared plus 8x cubed has the highest power, so the leading term would be 8x cubed. And similarly with that trinomial, 8x cubed is still the leading term of that polynomial. In example 1, we want to classify each of the given polynomials as a monomial, binomial, or trinomial, then state the degree of the polynomial and the coefficient of the leading term. Starting with part A, we have negative 4x to the fourth power. There's only one term, so this is a monomial. We can see that this polynomial has a degree of 4. Since the largest power is 4, we only have one exponent. And then the coefficient of the leading term, in this case, would be negative 4. Since we only have one term, that coefficient of negative 4 is our only option. In part B, now we have 3 terms, making this a trinomial. We would look at each of the 3 terms and find that highest power. In this case, that's 3. So this would be a polynomial with degree 3, or a third degree polynomial. And the coefficient for the leading term would be negative 8, since negative 8x cubed is the leading term in this polynomial, and the coefficient is just the number being multiplied by that variable. Then in part C, we have a binomial, since we have 2 terms. We can see that the largest power any variable is being raised to is 4, so this would be a 4th degree polynomial, or a polynomial of degree 4. Whichever term has that largest power is also our leading term, and that coefficient for the leading term would be 6 in this case.